Hi everyone, welcome to part 2 of lesson 9.2 and 9.4, the dot product. We're looking at some more applications of a dot product, and the first one is the projection of u onto v. And what that does is it creates a vector that's parallel to v, like this one here, that is a length of the component of u along v. So it's similar to what we were doing before, where if you took a light up here and you shined it down onto vector u and you got the shadow length here, it took that shadow length and created this new parallel vector. Okay, so that's the projection. Now, if I wanted to take that projection and actually write u as a sum of that projection and another vector, we would resolve vector u into the sum of two vectors. So we would use the projection as what we call u1, and we would take this vector here that would be perpendicular to vector v, and we would add that to it. And the way we would do that is take our projection and do u minus that projection. So notice our projection is going to be parallel to v, and our other vector is going to be orthogonal to v. Okay, so the projection of u onto v, that formula is u dot v over the magnitude of v squared times vector v. Now notice we're multiplying this constant by a vector. So this projection is a vector. Now to get this u2 value, you're going to do u minus the projection, which is going to result in another vector. These are vectors, not numbers. Let's take a look at an example to see if we can clear up exactly what's going on here. In this example, we're given u is -2, 9 and v is -1, 2. In part A, they want us to find the projection of u onto v, and in part B, they want us to resolve u into u1 and u2, where u1 is parallel to v and u2 is orthogonal to v. So I would recommend starting out by finding the dot product of u and v and finding the magnitude of v and squaring it. Then you can use the formula for the projection of u onto v, and that will help you find part A. So try and do that, and then press play to see if your answer is correct. For my dot product, I did -2 times -1 and 9 times 2. I got +2 plus 18 is 20. Now for the magnitude of v, I did -1 squared plus 2 squared and the square root of that. That comes out to be the square root of 5, but I need to square that, and the square root of 5 squared is just plain old 5. So now I need my formula. It's u dot v over the magnitude of v squared times my vector v. So I did 20 over 5, which comes out to 4, and 4 times -1 is -4, and 4 times 2 is 8. So this is the projection of u onto v. Now when we resolve u into u1 and u2, this is going to be u1, so I just have to copy that down. And now for u2, you have to do u minus the projection, and that will get you u2. So see if you can write both of those vectors, and then press play to see if you're right. So as I said, u1 is going to be this projection vector that we got earlier. And for u2, I copied down vector u, and I have to subtract out that projection vector. So -2 minus -4 is 2. And 9 minus 8 is 1. So u2 is the vector 2, 1. So both of these vectors, u1 and u2, are my answer there. Let's take a look at another application. As you know, work is force times distance. But when we're dealing with vectors, we actually look at it as the dot product of the force vector and the distance vector. And in most cases, in our textbook at least, it's measured in foot-pounds because we're dealing in feet and pounds. We're using the English measurements. Now, if you use the European measurements, you would deal with newtons and joules. but generally for our textbook, we're doing foot-pounds. Let's take a look at some examples where we need to apply force times distance, or force dot distance if we're dealing in vectors. In this example, it says a force is given by the vector F, which is 2, 3, and it moves an object from the point 1, 3 to the point 5, 9. They want us to find the work done. So notice they've given us the force vector here, but they haven't given us a distance vector. They've given us a starting point and a terminal point, but they haven't given us the vector. So the first thing you need to do is find that vector, and then you have to do the force vector dot the distance vector, and that will get you work. So pause the video and try and do that, and then press play to see if your answer is correct. So what I did is I did the terminal point minus the initial point. So I did 5 minus 1 and 9 minus 3, and I got 4, 6 for my distance vector. Then I just had to do force dot distance, and that's 2 times 4 is 8, and 3 times 6 is 18, and 8 plus 18 is 26. So this is 26 foot-pounds. Let's see another example. In this last example, it says a man pulls a wagon horizontally by exerting a force of 20 pounds on the handle. If the handle makes an angle of 60 degrees with the horizontal, find the work done in moving the wagon 100 feet. So notice they haven't given us any vectors here, but they have given us force values. So try to identify what we would use as the force vector and the distance vector. Okay, so we're going to be looking at the magnitudes here, and we've been given the angle in between the two vectors, so I think we're going to do the magnitude of the force vector times the magnitude of the distance vector times the cosine of the angle in between them. So see if you can figure all that out, and then press play to see how I worked out the question. So I made U the man's force vector, and the magnitude of that is the 20 pounds of force he's using. And I made V represent the distance vector. And we went a total of 100 units horizontally. So my horizontal component is 100. And my vertical component is 0 because he hasn't moved it vertically. He's only moved it horizontally. So the magnitude of vector V is 100 if you use the magnitude formula. And we do know the angle in between U and V, that's 60 degrees. So I'm going to use the formula that U dot V is the magnitude of U times the magnitude of V times the cosine of theta. So I did 20 times 100 times the cosine of 60. And the cosine of 60 is 1/2. So 20 times 100 times 1/2 is 1,000 foot-pounds. And that's the answer to this question. So that's it for this lesson. Let me know if you have any questions or if you need help with anything.